Hello, everybody. March 28th, 2026. Doc Hydro with you, and I got something that I wanted to share with you. I had an individual who bought one of my books, this book, and in that book, it had a question, or not a question, he had a question that he asked me, except it'd be a text message. So I'm going to get my phone here, and it's kind of late. He's a couple of states away, so I'm not going to I didn't get a response, but basically he asked a question which I thought was really good, and I cover largely to a degree when I'm teaching, and there's a couple of examples. But the question is that in the book I say, as a rule, if the head pressure exceeds or consumes up to 50% of the rated pressure of a single Mark III, then you need more than one pump for the job, often several pumps. And um, the question that he asked was, quick question, why do you recommend a head pressure of only 50% of the pump's max pressure? So again, I'm not going to mention the name, but that was the text message that I got. So I think it's really good, and I think we'll cover it this way, is that if you look at, and this applies to all pumps. This is not just a Mark III, but the Mark III has got the easiest pump curve, as you see here, to show and demonstrate this. So I'll cover it on the Mark III. But it applies to any centrifugal pump in the structure fire world, wildland firefighting, high pressure pumps. It really doesn't matter. But for our purposes, we're going to focus on the Mark III. So if we look at this, you can see that um, it maxes out roughly at around 380 psi. Okay. This is according to the engineering data. Okay. But this vertical line on the left, all the way down, I want you to notice something here, that is actually the zero flow line. So think about that a minute. If this is the zero flow line, but you got 380, that's standard pump terminology and specifics related to pumps. That if you're going to be at maximum operating pressure, you're at what's called in the pump industry as pump shutoff head or pump shutoff pressure. In other words, it's going to reach a certain point and then it's going to stop. That's it. It can't deliver any more than what it's got. So, also in the book, let me see if I can pull this up here. So, you can't really see it, but you can get these specifications from the Wajax website. But it shows that the maximum pressure is 380 psi. Free flow is 98 gallons a minute, okay, and the maximum head is 878 feet. So in other words, they just gave you both right there, 380 psi max or pump shutoff pressure, and then 878 feet is pump shutoff head. So again, you need to pay attention to that. But it's a good question that he asked, because why do I recommend that reason? Because if we use all of the pump's capacity to just get water from ground level, let's say this is the base of a hill, and using this curve, the pump curve, as a hill, if you need to get water all the way up here, you're going to consume every bit of pressure just to get water to that point. You've got nothing left over for flow, for whatever flow rating that you wanted, whether it's 10, 20, or 40, 60 gallons a minute, doesn't matter at that point, because once you've consumed everything that the pump has to offer, there is nothing else left. You're not supplying friction loss, you're not supplying nozzle pressure. It's done with. And so that brings about an interesting concept of what I think I would go over for a few minutes here, is that um, I responded via email. I texted him. I said I'll respond via email. I said, and then once I did that, he got it, because I attribute it to where we're setting up a design factor of safety. Okay, we are going to essentially look at this as the design factor, okay, of safety is the strength of a material divided by the stress that's applied to it, okay? And so in that case, that could be attributed to what our pump discharge pressure requirement is versus what the safe pressure is that the pump can deliver, okay? So that's how I want you to think about this is that you're designing a system. Remember, you're not going through a situation to where through my videos and whatnot to where you're going through a standard like S211 or an engine operator program or whatever to where you're just learning how to switch it on and get water out the nozzle. You're actually learning how to solve a problem and be successful. You're designing in a success factor based upon a factor of safety. And the factor of safety is actually a legitimate engineering term, but that's what it means. So the more appropriate way is that it's the strength in force units divided by the applied force or load. So imagine this. Imagine that you were going across a bridge. Engineers designed a bridge, okay? And they designed it for unity. In other words, if the bridge weighed X thousands of pounds and the required that the columns were of a certain size and certain diameter and height and everything else. And when they divided it all out, the strength divided by the applied force, it equaled one. They would say that, well, it's destined for failure because all it can handle at that point is itself. You put a car or a truck on it, and the chances of it collapsing or failing are pretty significant. Hence, that's what's going on here. So if we look at this from the Mark III and we go, okay, so we've got 878 feet, okay, and if we multiply that by our 0.434 multiplier, okay, for head pressure, and those that are familiar with that know exactly where I'm going with this. So if you don't, go back and look at some other videos. You have 380 psi. So if our PDP is calling for 380 psi, and we're using a Mark III to generate flow and pressure, okay, now there's a play there. I said flow, but it's going to flow water up to the point to where it gets to 380 psi, and then it's going to stop. That's basically what it is. So if we divide that by 380 psi, then you have one. So most people at this point would be thinking, hey, that's great. I can use one pump and get it up there. Time out. Remember. Remember what I just said. And let's go back to this graph here. If we're pumping 380 psi, from where that is, you come straight down, you've got zero flow. If I wanted to move 250 psi, well, I can only do so for about 38 gallons a minute. Okay. Or if we went to the opposite and say, hey, look, I want to flow 38 gallons a minute, what's that going to give me? 38, you go up on the pump curve and then look over, you're going to be about 250 psi. Out of this pressure, though, you have to supply the friction loss, you have to account for the nozzle pressure and your elevation pressure, since we're going uphill in this case. So, what I try to do is teach people that when you limit, okay, one pump and its pressure, if you've got an elevation that's going to be, oh, let's say, um, so 380 divided by 2, so that's 190 psi. So 190 psi is 50% of the Mark III's capacity. So out of that 190, if you're using a combination nozzle, there's 100 for that. So now you're down to 90. So out of that 90, you now have to sit here and think, wait a minute, I've got to supply elevation or friction loss. What's the friction loss going to be? Well, that's going to be based upon, and I've added this on the chart. So if you buy the book, okay, if you buy this book, a download file comes with it, 8 pages that shows you how to calc all this out with an example. And it gives you the friction loss in pounds per square inch per 100 feet of hose. So between the book and the sheet, you're learning how to actually think and design about how to make a system successful routinely successful, not just maxed out to the nuts all the time and hoping that it works or wondering why it ends up failing. Um, so getting back to this, if you're up at 380 psi, you're pretty much deadheading. You're at no flow. And I've already shown in previous videos that pumps become really good steam generators and can send people off to hospitals in a rapid amount of time. So, at any rate, so that was the question. That's why you're setting up a factor of safety that is being predetermined and built into your model, doing it the way that I do it. So that way you can guarantee yourself success at the end of the day. And by having that redundancy, the more pumps that you get, you're taking advantage of the other pump. So each pump doesn't have to work harder. And in engineering terms, in the mechanical, civil, industrial engineering fields, you're commonly taught to not max out a machine element or any type of a component to its maximum rating. You always want to keep the stresses back a little bit, and so that's what we're doing here. Yeah, it calls for more pumps, but when you use more pumps, you're guaranteeing yourself that success. So anyway, the other thing, the last thing I want to talk about is that with that download file is this, the Mark III pump capacity cheat sheet. Right here, this section, not required that you guys don't have to worry about. It's not required. It doesn't need you to do the um, slope ratio. But the reason I've included it is because I show you how to get the true slope ratio. If you're down over here on the bottom and you know what the elevation is up on top, you can get that slant distance and then you can get the vertical distance, okay? Once you get that, you use this equation, you can get x1, which is the true horizontal distance. And on that horizontal distance, if you're on the ground and you need to say, or you think to yourself, it's like, you know what, we really need to get a pump at that point there. What is that distance there? And you say, okay, well, that's 1,786 feet. Well, you're going to be able, with the slope ratio, to so 1,786 times whatever the number is. It could be like 0.1118, and then it will tell you what the elevation in feet is, and then from there you can determine the pressure to see if it's like, okay, hey, yeah, we should still be good there. Our pumps that we got in place now should still be able to get water at the rated flow and pressure at that point. Great, okay, and then you can go up the way. So it's another tool that you can use to determine hydraulic feasibility without actually having to be physically on the site. And then it's like I said, it's 8 pages. It's got the pump diagram again, or the pump curve. And yeah, so it was a good question. So I thought I would cover that. Anyway, that's it. Have a good one.